Welcome to session 19, angle types and special sums. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to classify acute, right, obtuse, straight, reflex, and full turn angles. Use complementary, supplementary, and around a point sums. Estimate angle size before solving an equation. Keep the diagram, the calculation, and the unit connected at every step. Start with concept visual. The complementary and supplementary pairs use different benchmark sums. The triangle angles give another important 180-degree relationship. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. If two angles form a straight line and one is 128 degrees, the other is 180 degrees minus 128 degrees equals 52 degrees. The drawing should show one obtuse and one acute angle, confirming the result. Angle work is organized around benchmark sums, 90 degrees at a right angle, 180 on a line, and 360 around a point. Trust markings and stated relationships, not visual appearance. Diagrams are communication tools, but they are not guaranteed to be drawn to scale. Now add a precision check. Write each relationship beside the diagram before forming an equation: equal, complementary, supplementary, or a full turn sum. Preserve degree units, solve the algebra, and substitute the value back to confirm every angle is positive and every required total is satisfied. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, identify the vertex and the two rays that form the angle. Second, choose the correct benchmark sum, 90 degrees, 180 degrees, or 360 degrees. Third, write an equation that includes every part of the benchmark angle. Finally, solve and compare the answer with the sketch's acute or obtuse appearance. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. How many degrees are in a straight? Step 1 is to organize the information. Identify the vertex and the two rays that form the angle. Step 2 chooses and sets up the relationship. Choose the correct benchmark sum, 90 degrees, 180 degrees, or 360 degrees. Step 3 carries out the mathematics. A straight measures 180 degrees. A useful check is to memorize 90, 180, and 360 as anchor angles. The answer is 180 degrees. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. What is the complement of an 18 minus degree angle? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 72 degrees. Complementary angles add to 90 degrees. 90 minus 18 equals 72. A useful check is to memorize 90, 180, and 360 as anchor angles. Use this coaching check as well. Never trust a diagram to be perfectly to scale, but do use its broad angle type as a reasonableness check. Session recap. First, identify the vertex and the two rays that form the angle. Next, choose the correct benchmark sum, 90 degrees, 180 degrees, or 360 degrees. Then, write an equation that includes every part of the benchmark angle. Finally, solve and compare the answer with the sketch's acute or obtuse appearance. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.